So far, we assume the minimum rate of return in our analysis is fixed over the lifetime of the project and it's not changing over time. But there are situations that we might have other opportunities for investment later on in the following years. So our minimum rate of return might change. And it means that the discount rate, the minimum discount rate that we are using in our analysis will change too. In this video, I'm going to explain how we can evaluate the mutually exclusive projects, or in general any other project, if the minimum rate of return, if the discount rate changes over the lifetime of the project. So if the minimum rate of return changes with the time, the NPV and PVR, present value ratio, are recommended as the best methods, and rate of return is not a reliable approach for the project evaluation. Let's work on this example. We have the cash flow for project A and project B that are mutually exclusive, and we assume the minimum rate of return for the first and second year is 25%, and the minimum rate of return changes to 15% from year 3 to year 10. So the first thing that we have to do is to separate the payments before the change and after the change. So here, minimum rate of return changes after year 2. So I draw this red vertical line here to separate the payments before this year and payments that are after year 2. Of present value of 40, present value of these 20 payments at year 1 and 2. So present value of 40 is $40, and it is negative because it's a cost, it's an investment, and it's happening at present time. So there is no discounting needed here. But we have two payments of $20 at year 1 and year 2. We discount them at 25%, and there are two of them. And then we need to calculate the present value of payments that are happening after year 2. These payments are going to be affected by the change in the minimum rate of return. So first we need to calculate the present value of these payments at 15% rate of return to the year 2, and then after discount that present value for 2 years with 25% of discount rate. So here we have 8 payments of $20. So we discount them to the year 2 by the 15%, and then after we discount that by 25% for 2 years. That is going to give us the present value here. And for the salvage value, it's the same. We discount the salvage value for 8 years at 15%, and then we discount that after for 2 years by 25%. So we use this method to calculate the present value, net present value, NPV, for two mutually exclusive projects. And as we can see here, project B has higher net present value. So I'm going to show you how we can calculate this in Excel using the other method, calculating the present value of each payment and then add them back together. So I have the cash flow of project A here, cash flow of project B, and I wrote the minimum rate of return here for each year. So as we can see here, we have 25% for year 1 and 2, and we have 15% from year 3 to year 10. So cash flow of project A, cash flow of project B, and for the last year, I added the salvage to the annual payments of the last year. So project A, I'm going to calculate the present value of each payment in this cell. So present value of these $40 of investment is going to be the same as $40. It doesn't need to be discounted because it is happening at the year 0. So present value of the $20. So I write equal sign $20 divided by 1 plus interest rate power the year. So this is not going to be affected by change in the minimum rate of return. So these 2 years are the same. So I just apply this equation for the year 2. But for the year 3, how do I calculate the present value of this $20 that is happening at year 3? So it is going to be affected by 2 interest rates. $20 divided by open parentheses, okay, 1 plus 15% power. So this needs to be discounted for 1 year because interest rate is because minimum rate of return changes at year 2, and this payment is 1 year away from year 2. So I write year 1, and again I have to divide that, I have to discount that by 2 years, because this is going to give me the present value of this $20 here, and then I'll need to discount that at the rate of 25% for 2 more years. So 1 plus 25% power 2, and this is the same for the rest. So in order to apply these to the other cells, I will just write for this, say okay, read the year from here and minus 2, which is the year that the minimum rate of return changes, and I apply this to the other cash flow. And the same for project B. Investment at present time is the same. For year 1, it equals 1 plus 25% power the year. For year 1 and year 2, they are similar. For year 3, this is 25 divided by open parentheses 1 plus 15% interest rate power year minus 2, and again this divided by 1 plus 25% power 2, and I apply this to the end. So these two should give me the present value, and I calculate the NPV for project A. NPV for project B. NPV for project A equals the summation of all these present values, and the same for B.